some answers that you want your volunteers to mark. And that's it. You have a working project. So what's missing is that if you want us to publish this project, you would only need to go through a beta phase, a beta, and then yeah, you would have a live project. Right. So you could see that with the Easy Project Builder, there's just been a lot of projects going live. And with the amount of projects that are going live, you have more and more images, but the rates by which the volunteers increase have not been the same. So we have to deploy artificial intelligence and machine learning in order to to streamline this process. So yeah, so all machine learning needs really is large training sets. But to get those large training sets, you have to have the volunteers for them. So it's kind of like a step-by-step process. So to tackle this, let me first mention the Zorilla problem, which is in case you haven't heard. So let me first start by showing you these images of like common species that you might find in the images. And machines are very good at finding common images. But when hit with an image like this, they often would probably write this as a skunk or something, depending on what the training data has, because the Zorilla is a very rare animal. And also, let's say you have images of penguins, but then you find a bear. Your machine learning model would still think it's a penguin because it just wasn't trained on a penguin on a bear that wears a penguin head on it. So what we really want to focus our volunteers on is the known unknowns, which is the Zorillas, and even the unknown unknowns, which are the things that even scientists don't know about. Think of it as like if zebras don't exist in Africa, and you want your volunteers to look at your images to find that there's a zebra, even though you don't know that zebras don't, even though you know that zebras don't exist there, or zebras don't even exist on Earth. So what you really want to focus your volunteers on are serendipitous discoveries and rare things in the data, and you want your machine learning models and processors to go through your data and filter out things that you already know. So to do that, we created a decision engine called Caesar that looks at the labels by the volunteers, extracts them, and then comes up with an action based on the labels. And having those actionable decisions, we streamline it through our app, and this just makes the whole process a lot faster, and it makes finishing labeling the images a lot quicker. So another way that we do things that optimizes crowdsourcing is label validation. So instead of taking these two images and telling volunteers, okay, label these images, what classes are in these images, instead of that, if we already have a model that distinguishes empty landscapes and elephants, we can get a confidence, and then we would upload it, and then we would filter out based on the species that we already know, the common ones. And then all volunteers need to do really is to validate what the machine has already written, and then predicted. And based on those validations, we can actually speed up the retirement and just speed up the whole process. And in a data set that contains 22% empty images and 48% vehicle images, you would filter out a lot of images, and you would need 43% fewer volunteer classifications. So just by doing that. and you would maintain the same accuracy. So yeah, another tool that we do, another method that we do is active learning. So what if the model already knows what a line is, but it wants to see the line from a different perspective? So by showing images of the line in a different perspective to the machine, you can actually get more accuracy. So by filtering out the images on the right and only giving the volunteers the images on the left, we increase the accuracy and we decrease the amount of data necessary for the model. And this is actually live on Galaxy Zoo at the moment. So how do we push boundaries even above active learning? So since active learning focuses on subjects that contain the most amount of information, sometimes it gets difficult for volunteers, and we're all about volunteer experience. And we don't want them to focus only on the hard subjects. We also want them to enjoy labeling, and to do that, we could have levels of labeling. So in first level, let's say you'd have easy images that are clear, and then the further you go, the better the expert the volunteer becomes, and the more discussions that they've had that they would have with the researchers. And because they're going to be better experts at every level, at level 7, let's say, they would actually be able to identify something completely missed by the researchers. They could. Another way of doing of optimizing crowdsourcing is to actually make use of the structure of the data. So by identifying the clusters of the data and the similarity between images, we can actually classify images 36 at a time, or a grid at a time, instead of one by one. So in this project, we're looking to classify muon rings, and just for a brief background, so muons are created by gamma rays that hit our atmosphere and and that create showers of particles, and then these particles go on to onto telescopes, and that's how we get muon rings. And so the task here was for volunteers to classify these muon rings, and by doing this, they classified these 4, and also classified the other 32 because we've already used the structure of the data. So after the classification, we can actually use a machine learning model. So by using clustering and unsupervised learning, there was no need for volunteer labeling until this validation step. So this is actually 20 times more efficient label gathering, and this is 20 times more, not 36, because we accounted for the inaccuracies that could happen. So there might be multiple runs of this validation. So some concluding remarks. So why would our volunteers participate? Because of the communication with the research team, the live discussion, the presence on talk boards, the Q&A sessions, the open source data that they give the researchers and that they see, the access to results and publication, and then the acknowledgement and credit of the work that they've done. And this is in a recent survey that we gave our volunteers, which is why would they volunteer? Which is mostly because of the contribution that they give, the interest, and just the entertainment of the labeling process. So to conclude, I just want to point out that one of the main Zooniverse design principles is just to maintain low barriers to entry and broad accessibility, which is we want our volunteers to be able to access data and research and we want our scientists to easily create projects, and really everyone to create projects. And this is just to show how the Zooniverse participation was during lockdown last year, and it increased during COVID. So what is the future of people-powered classification? So it's to shift work from humans to machines, which is a must given the growing data volumes. Machines need training, so humans must guide the machines to some extent. Also incorporating model prediction to human workflows to make it more efficient. And we would also need to combine machine and human classification, just to, because it's less both. And we need to point out that some tasks are just uniquely suited to human intervention because they are rare and they can't really be modeled by a few data samples that we can get. Yeah, so thank you, and thank you to all of our volunteers.
Thank you very much. Thank you very much. Any questions from here, from Israel? Dan, once again, Dan.
Hi, Suhail. I was just wondering, what's the average number of volunteers per project that you have, and whether you have any data on how long they remain associated with the project, whether they volunteer on a single project or several projects, just those kind of general statistics on it. Thanks.
Yeah, so the number that I gave you, the number of volunteers, which is 2.3 million. So actually 1%, around 1% or 5% of that number is the number of volunteers that actually do the majority of the work. And about the number of volunteers for each project, so it actually really depends on the project itself. A project that would include images that are that draw the public into them have more volunteers just because of the interest of the public. So it really depends on the exact project and how easy it is for a project for volunteers to label those projects. Does that answer your question?
Nods, yes, I guess so. Yeah, Tanya has a question.
There's also a question.
There is a question from
The chat.
Okay, you go first.
what is the bias in terms of for long-term projects? How much effort goes into, let's say, identification individually, and what kind of bias does that typically result in for the algorithms, especially when there is data drift over time?
I didn't hear the first part of the question. Can you repeat the first part, please?
What kind of bias is there? Have people estimated the bias that is results over time from both the attrition in participation in long-term projects as well as the data drift in long-term projects, because the annotations that are done at the beginning of the project may not be relevant they may bias algorithms as different data come in. Okay.
So about the volunteer bias themselves, because some volunteers might quit and you'd get new volunteers. So the way we validate that is by having expert labels and having expert labels, and then comparing the expert labeling with the volunteer labeling. About the data drift, so it really depends on what the project, how long the project stays. So for Galaxy Zoo, for example, it's been going since 2007 until now, and it's really project dependent, and the scientists themselves, after getting the data, the labeled data, they would work on the data drift. And some projects finish within a week or so.
All right. I see Tom has a question through Zoom. Can you unmute yourself and just ask?
Yeah, sure. And yeah, I guess more of a comment. One of the great advantages of having this sort of human in the loop, human validated approach where your user just kind of swiping left or right, whether they agree or disagree, is you can find those observations where the AI thought it got it right, but all the humans are saying, no, you got it wrong. And that's really great training data, right? That's like a fantastic kind of side effect of that approach as you get this cool training data. So I was just wondering if you've used that and if you've got any information about how that disproportionately perhaps improves your models compared to traditional training data.
So I don't have exactly the numbers behind just training on that data, but those disagreements are actually fed back to the manual labeling process, which is to identify what exactly is in there, because you want the volunteers to actually tell you what's in there. Like, for example, if you say that an image has penguins and it actually has a bear, if the volunteers disagree, then you would want some discussion around that exact subject. But yeah, I don't have exact numbers on the training. Just using those.
All right. Ron, did you have any question over here? You did not. I thought you did. Any other questions? All right. So thank you so much, Suhail. Thank you very much. We are now going to have